So function operations, there's 4 of them. Okay, so they're just like our normal operations: add, subtract, divide, multiply. Okay, so you probably remember this from maybe a little bit from Algebra 2. So understand here, f and g, they're not variables, but they represent functions. Okay, so if I add 2 functions together, of course, that's called adding. Okay, that's no big deal. So this would just basically mean I would take whatever the function f was and add it to the function g. So really all it amounts to is just combining like terms. Okay, that's it when you add. All right, now, so if you have adding, by the way, this is the function operation of addition. All right, the other one, take a wild guess here. Subtracting, okay, subtraction. So this means you just subtract the 2 functions. Okay, now when you subtract the 2, one thing you got to be careful, you may want to make a note about this. When you subtract like that g function, you wouldn't just subtract the first term. You subtract the whole function. All right, what's another way of saying that? Especially with that negative sign instead of subtract. What if it's like a function that's got 3 or 4 terms into it? What now? Distribute it. Okay, so make yourself a note. You've got to really more so than subtract it to distribute that negative sign and then combine your like terms if you have any. Of course, that's subtraction. Okay, now this one, closed dot, because open dot's going to mean something else. This is obviously just multiplication. Okay, so this means I would just do f of x times g of x. Dang, multiplication is a long word. All right. Okay, now here's sometimes where we're going to have a little bit of issue with the domain, and it's division. So f divided by g. Okay, so this would just be taking the 2 functions and dividing them. And a lot of times there's really no work to do. You just put one function on the top of a fraction, the other function on the bottom. So the only time really you can do anything with division is like if you can factor and cancel. Okay, now, so obviously division. Now we're going to restrict something here though. What's something that has to be true here when I'm dividing? Right, g of x cannot be 0. Because we can't divide by 0. Okay, so that's something that we're going to remember when we talk about domain. Now, the domain of a function versus the domain of a function operation is a little different. Okay, we'll get into that rule after we start. Let's just focus on the operations right now. Okay, so let's look at this example. Okay, and if you want to make yourself a little note here, this will be like number 31. Okay, this is really good, easy one to start off with. Okay, now what they're going to ask you for is they're going to ask you for all 4 operations. They're going to say do f plus g, do f minus g, f times g, and f divided by g. Okay, and this one's pretty simple here. So let's start off with f plus g. So really we can probably do this one in our head. So what does this mean I take the 2 functions and do? I can't imagine what. Add them together, right? Okay, that's it. So I'm not even going to write them down. Just add them together in your head and tell me what it's going to be here. What? 7x minus 5. I only have to show you work with that. Okay. Now, with subtraction, though, I'm going to be a little bit more careful. I'm going to write this one down. Okay. So f minus g, this will be 6x minus 9. Now, when I subtract the g function, right, you got to distribute that negative. Okay, you don't just subtract the first term, you subtract all the way through. Okay, so it ends up being minus x, but then minus 4. Okay, now let's clean it up. So that would be 5x minus 13. Okay?
Attention seekers, if you are unscheduled after third or fourth period and need a cap and gown picture, report to the auditorium now. Any senior who is unscheduled after third or fourth period needs a cap and gown picture, report to the auditorium now. Thank you.
All right, now, FG just means F times G. Now, a lot of like Algebra 2 books will put a dot there. College books don't put a dot there. So, you might see it with a dot, you might not. Okay? But it just means multiplication. So that means I'm going to multiply this times that. Now, how do we multiply two things like that? Yeah, parentheses, So, and I think somebody said kind of what we're going to do after we write this. Yeah, distribute, or sometimes like I call it, Ms. Free calls it double distribute. I call it the full method. Either way, it's the same difference. Okay, so let's FOIL it out here. This will give me 6x squared plus 24x minus 9x minus 36. Okay, now all I got to do is get my like terms together. So we get 6x squared. Let's see, help me out. 24x minus 9x would be 15x minus 36. Okay, now let's divide them. So F divided by G. Now this one, it's not going to have a whole lot to it. All right, because really, when you do F divided by G, all right, I got to look at them. 6x minus 9, all right, divided by, was it x plus 4? Okay. Now, the only way I'm going to be able to do anything with that, like cancel out, is to factor, right? So if I can factor and get a common factor and make the operation multiplication, I can cancel anything out. You could factor out a 3 in the numerator, okay? You get, what, 3 times 2x minus 3. Would anything cancel out, simplify? No. Okay. Now, it did say to find the domain. We're not going to talk about the domain just yet. We're going to come back to that after my next example. Okay. But one of the things that's not going to be in that domain here is going to be -4. Okay. Because we can't divide by a 0. All right. Now, let's look at another. This one's not too bad either. And let me just ask you guys if it's okay here. For F plus G and F minus G, do you mind if we just skip those? Y'all okay with that? Okay. So we'll just skip those since that's not really going to be that difficult. Okay. Now, F times G, though, you might need a little bit of help here. So let me do this one with you. So that just means I'm going to multiply the functions together. So 3x squared plus 23x plus 14 times x plus 7. Okay, so now let's multiply it out. Now here's the thing. This is not the full method. This is not double distribute. Because it's not a binomial times a binomial. It's a trinomial times a binomial. So I guess we could say triple distribute. Okay, so it's not the full method because there's actually going to be 6 terms. So what I can do is I can take 3x squared and distribute it to x plus 7, and then take 23x and distribute it to x plus 7, and then take 14 and distribute it to x plus 7. Okay, so we'll multiply 3 different times and distribute. All right, so start with 3x squared. All right, 3x squared times x plus 7 would be 3x cubed, okay, plus 21x squared. Okay, now let's distribute 23x. I'm going to need some help with 23 times 7. Y'all punch that in for me. All right, 23x times x would just be 23x squared. All right, 161, that would be 161x though, right? All right, now let's distribute 14. 14 times x is 14x. Okay. All right, 98. 14 times 7 is 98. Well, it's a good thing that's all I had to do. I ran out of room. All right, now let's combine my like terms. Nothing really is going to go with 3x cubed. Okay, 21x squared and 23x squared would be 44x squared. And then 161x and 14x would be 175x. And then we'll bring down the 98. Okay, so really not that big of a deal. Okay, but it's kind of cumbersome there. So it's just sort of like the distributive property, instead of 2 times, it's 3 times. Now, let's look at the f divided by g. Okay, this one will actually have something to do this time, unlike that last example. It's like 3x squared plus 23x plus 14 divided by x plus 7. Alright, so we said the only way we can cancel out, this is why we did rational expressions about a week ago, so when you get to this, you would know how to do it. So we have to really do what here to get something done? Factor. Okay, and that's kind of a hard trinomial factor. Right? And we're not looking for factors of 14, but factors of 3 times 14, which is 42. So let's see, can y'all come up with factors of 42? Yeah, 21 and 2. Yeah, 21 and 2. Okay, so let's see, and I've got to split that, don't I? Okay, so let me bring that down and just factor it. Okay, and then I'll actually, so I'm going to do it scratch paper. All right, we said, what was it? 21 and 2. Okay, so 21x and 22x. All right, signs the same, they're both plus. Okay, now let's group them. So I can factor out of that first group 3x. That'll leave me with x plus 7. Now, I'll look back up at the problem. It's going to end up simplifying, isn't it? Okay, it's a good thing I factored it here. All right, now out of 22 and 14, you can get out of 2. Oh, it's 21. Oh, 21 and 2. What was I doing? Okay, there we go. So you can get out of 2 there. So I'm going to say it was plus 2 though, wasn't it? All right, so get out of 2. That'll give me x plus 7. So we can get x plus 7 times 3x plus 2. Okay, now let's write that one out that way. We get x plus 7 over 3x plus 2 over x plus 7. And so we know now that that's going to simplify. So my answer is just 3x plus 2. Okay, that one wasn't too bad either. Now, let's bring in, I'm going to go back to my first slide here, and we're going to look at the domain. Okay, so these are my function operations. Okay, let's talk about the domain of them. All right, now this is going to bring in something here that was on your quiz yesterday, which some of you, I don't think you grasp yet, so maybe you can kind of get it today. It's going to be intersections. So remember when you do an intersection, to find out where the intersection is, you do 2 graphs and you look where both of them are. That's what we're going to be doing here in a minute. Okay, so for the domain here, now I'm not talking about the domain of a function. I'm talking about the domain of a function operation. Okay, so we'll look at the domain of a function operation. Okay, now this is pretty difficult. This is where usually people get lost because it's new. Because you see that other stuff in algebra too. Now, it works like this, and I got my book open so I can be sure that I got it right, okay? When it comes to sum, difference, and product, okay? List them. So sum, difference, so that would be like adding, that would be like subtracting, and then product would be what? Multiplication, okay? These three, you do the same thing, okay? So what happens is usually these three end up having the same domain, okay? Now not the functions. Remember, we're finding the function operations, okay? So let me tell you what the domain of the function operations are now, okay? So for two functions here, let's say for f and g, okay? For f and g, f and g represent functions. The domain is, okay, and we'll write this kind of slow here. Now, you got to understand my notation. I'm going to say capital D sub f. Okay, you can probably figure out what that's going to mean. Okay, intersect. Remember, that's intersect. What the union is upside down from that. Okay, so it's the domain of f is what that stands for. Intersect the domain of g. And that's how you find the domain of a function operation. Okay? So you have to find the domain of both functions, and then you have to find the intersection of those domains. Okay? So it gets pretty deep. Now, the fourth one is, of course, the quotient, or in this we call it maybe division. Okay? You don't really have to use the word quotient. Okay? The quotient is the same thing, but it's going to have like a, sort of something else we're going to have to add to it. Okay? So for the quotient, it's the same thing. And let's say that this is for the quotient for f divided by g. Okay? So it's the same thing. It's the domain of f intersect the domain of g and something else. What else do we have to worry about with division? Right, so g cannot be 0.
Attention seniors, we need all female last names H through M to report to the auditorium at this time for cap and gown pictures. If you are a female last name H through M, report to the auditorium for cap and gown pictures. Thank you.
All right, now one of the things you're going to have to think about here is what the domain of f is, what the domain of g is. You have to find the domain of two functions and find their intersection. Now, you remember how we found the intersection? We didn't really use set builder notation. We used interval notation because we drew number lines, didn't we? So we're going to have to sort of think in interval notation now. Okay, so it gets pretty complicated here. Now, back to the first one that we did. Now, this one's not going to be very hard. Okay, so let's start off, and when I'm finding the domain for the function operation, now when it says each function, it doesn't mean this function and this function. It means for this, 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 and this. Okay, probably a better way to say that is should have said determine the domain for each function operation is what it should have said. Okay, so now let's just look at the domain of the functions. Okay, so what's the d sub f going to be here? What would be the domain of the f function? Are we dividing by anything? Are we taking a square root? All reals. Okay, this one's going to be pretty easy because of that. Okay, now what's the domain of my g function? All reals. Okay, now let's find the domain of f plus g, f minus g, and f times g. All right, so you remember what those were? How did I say it? Let's go back and look at it. It's the domain of the f intersect the domain of g. Now, if I intersect all real numbers with all real numbers, guess what you get? All real numbers. Okay, so the domain, that's the nice thing about when you have f plus g, f minus g, and f times g, their domains are all going to be the same. Okay, so all of these, their domain is going to be all reals. Okay, yes? Wait till we get to one that's going to have some restrictions. Okay? Now, I'm going to give you answers to this, and I'm not going to put that on the answer key. Instead, it's going to be an interval notation, so it'll probably look like that on the answer key. You can give me either one. Okay? Now, so I did these three together because it was just the domain of one function intersect the domain of the other function. Okay, so it's all reals, so it's just going to be all reals. Now, when we got to f divided by g, then we had a restriction. Okay, so we actually said this earlier. It would be all reals except for -4. Okay, there's really no big deal on this one. All x such that x cannot equal -4. Okay, now let's look at the one. The one that we just did here would be really similar. Okay, what would be doing f and g? What's the domain of f? All reals. What's the domain of g? All reals. So the domain of f plus g, f minus g, and f times g would be all reals. We haven't got to a hard one yet. Okay. Now, f divided by g will be all reals except for -7. Okay. Now, y'all see why I'm getting -7 from? It's not because it makes it 0 there. It would make it 0 right there. Okay, I'm not going to worry about writing that one down because it's so similar. Now, let's get the one there that's really, really challenging. Ah, yeah. That's going to be fun. Okay? Try to control your enthusiasm here. Okay? All right. Now, all right, let's start off with f plus g, okay? So, here we go. F plus g would be 2 plus 1 over x. All right, y'all tell me the rest of it. What would the rest of it say? That's f. Now add g to it. What's g? Yeah, plus 3 over x. Now that's not as bad as it seems. Let's take a look. They already have a common denominator right there, right? So those would be like terms. Okay. So I just bring down my 2. This would be 2 plus 1 and 3 is 4. Now, would I say x plus x is 2x? Right, you just keep it the same because the common denominator is supposed to, you don't change that, do you? Okay, that's it right there. Okay, now let's look at f minus g. This is not going to be much different. So this would be 2 plus 1 over x. Now this time it would just be minus 3 over x. Yes. Well, we're going to go back and do that at the end. Okay, because the thing is, whatever it is for f plus g, it'll be the same for f minus g and f times g. So we'll get like 3 things done at once. Okay. Now, so let's see. In this case, we'd say the 1 minus 3 right here and right here would give me -2. Yeah, so it would be 2 minus 2 over x. Okay, now let's do f times g. This might be a little bit challenging right here. So f times g. Okay, so let's see, f was 2 plus 1 over x All right. What was G? Was it 3 over X? Yeah. Okay. Now, this would just be distributing, right? Okay. So most of the time when we distribute, this would kind of look backwards. All right. But let's see. 3 over X times 2. Just multiply numerators, multiply denominators. 3 times 2 is 6. And X times an understood 1 right there would just be X. Okay. It'll help me with my next one here. All right, 1 over X times 3 over X. What would that be? 3 over, right, X or X squared? X squared, because you're actually multiplying. It's not like adding where they stay the same. Okay. Now, let's talk about all three of them. Now, when I talk about the domain here of these three, see, they're all going to have the same domain, whatever that is. Come on, pen. There we go. All right, so domain. Now, so what do I need to do? I need to like look at this, all this stuff right here to find the domain? Nuh-uh. All right, let's go back and remember. Let me flash it back, okay? The domain, what was it? Here we go. All right here. So we're going to keep going back to is the intersection of the domain of F intersect the domain of G. Okay? So that means where they overlap each other. Okay? And there again, you may need to go back and watch that video from Career Day when you're out, because you're still missing that. All right? Now, here we go. Okay? So what we need to look at is the domain of F and the domain of G. Okay, so y'all look at F there. Okay, what would the domain of F be? X cannot be 0. Okay, so I'm not going to put it in set notation because it's not my final answer. Okay, and now the domain of G be the same thing. All right, X cannot equal 0. Okay, so if I intersect those two, they say the same thing. So what's going to be the domain of F plus G and F minus G and F? What? X cannot be 0. Now this is where I got to put it in my notation. For all X such that X cannot equal 0. Okay, I know this is probably still not making like a whole lot of sense here. Just wait till the next example. It gets fun. Okay. Now, we didn't do division. All right, so we got to do division. All right, so 2 plus, let me write it down here. So let's see, F divided by G. All right, y'all look back on your paper and help me. What was F? Okay, and then G was 3 over X. Now, we should know how to handle that, right? Yeah, multiply everything by X. All right, aren't you glad? We did all that rational expression stuff. This is why I did that. So when you got to this point, hopefully you guys would be okay. All right, so I'm going to simplify here. So this will give me 2X plus, as we cancel, that would be just 1 over 3. Okay, now the domain is going to be just like the other three. We're going to say X cannot equal 0 plus something else. Now, what was the G function? 3X. Okay, so it's the same thing. It's the domain of one intersect the other, and G cannot be 0. Now, here's the funny thing about this one. What's going to make that equal 0 right there? 0. So we really didn't find anything new, did we? Okay, so coincidentally, the domain of F divided by G is the same thing there. Okay, that X cannot be 0. All X such that X cannot equal 0. Okay, so it ends up being the same thing for all of them. Like right here. I was just remembering what g of x was. Okay? Because the thing about the division one there is it's the same as what the first three was, plus this right here cannot equal 0 either. So with division, you have to take like an extra precaution. It just so happened that I got 0 again. Okay? So what if I'd have had, what if g was x minus 3? We'd have had x cannot equal 0 or 3.
So it's always going to be x on the g part. It's always going to be x cannot be 0 and whatever else is going to be.
Well, it depends on what g is. Okay. So it still can't be 0. So it's the same thing. All right. So it really didn't add anything to the problem. Now, oh, this one's going to be real fun. All right. Now, what's going to happen when we add and subtract? Nothing's really going to be significant. Okay. F plus g would just be the f one, x plus the square root of 3, plus the g one, square root of x plus 1. Now, can you actually combine the like terms there? Right? Can I like combine something like this? Is that square root of 5 if I do that? No. Okay. Now, could I do this and that be square root of 6? Yes. All right. Don't worry about the last question. Okay. We'll address it tomorrow when I can get through with this one. Okay. Do everything but the last question for me in your homework. Be sure you copy them down over there. 30, 31, 35, 41, 45. Okay.